So chapter 11 of the Applied Year 1 textbook is on variable acceleration. So let's just straight away look at example 1. And in this section we're dealing with functions of time, so we're going to be given equations for distance, velocity and maybe acceleration in terms of time. So example 1 says a body moves in a straight line such as displacement s meters from a point O at a time t seconds is given by s for displacement is 2t cubed minus 3t, where t is greater than 0. I mean, in almost all these examples we're assuming that t is always going to be equal or greater than 0 because t cannot be negative. So it's important to understand the difference between displacement and distance. So for example, here's our starting point. You travel 3 meters. Your displacement from the starting point A is 3, and the distance travelled is also 3. But were you to then come 1 back, you will have travelled 4 meters in total. Your distance travelled would be 4 meters, but your displacement from the starting point would be 2. Another meter, distance 5, displacement 1 meter. If you return to the starting point, you've travelled 6 meters as your distance, but your displacement is 0. And then if you go to the left of the starting point, say another meter, then you would say the displacement would be minus 1. So generally we say to the right positive, up positive, down negative, left negative. Not always, but in most cases. Okay, so in this example, we've got the equation for the displacement, and part A asks us to work out s when t equals 2. So all we need to do is substitute t equals 2 into this equation. So s equals 2 times 2 cubed, so that's 8 times 2 is 16. Take away 3 lots of 2, take away 6, which is 10 meters. So that tells us after 2 seconds you'll be 10 meters from your starting point. B then asks us to work out the time taken for the particle return to O to go back to the starting point. Well, when it returns back to its starting point, your displacement is 0. So we'd have 2t cubed minus 3t equals 0. If we then factorise t out, you'd have t brackets 2t take away 3 equals 0. So we'll have t equals 0. Well, initially you're at the starting point. When t equals 2t equals 3, so t equals 1.5. So it'll return to the starting point. Oh, sorry, it was 2t squared. So 2t squared equals 3, t squared equals 1.5, t equals square root 1.5. Which we can on the calculator is 1.22 seconds. Okay. Obviously, because we're square rooting, it could be, well, it could be positive or negative. You can't have negative times, so it's just going to be the positive solution. Okay, on to example 2. It says that a toy train travels along a straight track, leaving the start of the track at time t equals 0. Okay, that's pretty obvious. It then returns to the start of the track. So say this is the start of the track, choo 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 choo, choo 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 choo, comes back on itself. The displacement is given by 4t squared minus t cubed. And you're asked to explain the restriction that t must be between 4 and 0. Well, we're told in the question that starts when t equals 0, so obviously t must be greater than or equal to 0. But what about why is it less than or equal to 4? Okay, so let's work out the time it takes to return to the starting point, which presumably is 4. So presumably it takes 2 seconds to get to the end and another 2 seconds to get back if it's symmetrical path. So let's work out what happens when it returns to its starting point. So if we factorise t squared out, and s must be bigger than or equal to 0, because it can't go to the left of the starting point. Now, these two things are multiplying one another, and if we're multiplying two things and the answer is positive, either they're both positive or they're both negative. Well, in this case, they must be both positive, because t squared cannot be negative, because when you square something, that itself must be positive. So because that must be positive, this must be positive. So we've got 4 minus t must be greater than or equal to 0. So 4 must be greater than or equal to t must be less than or equal to 4. So we know it starts when t equals 0, so t must be greater than or equal to 0. So therefore t must be between 0 and 4. Okay, on to example 3. In this example, we're told that the velocity v is given by 2t squared minus 16t plus 24. We're asked to find the initial velocity. Well, the initial velocity is when t equals 0. So the initial velocity, which we sometimes call u, but we'll keep it as v, it's going to be 0, 0, 24. So the initial velocity is going to be 24 meters per second. We're then asked to work out the values of t. Notice it uses values, so we're going to have to more than one answer when the body is at rest. Okay, so it starts with a speed of 24. It's probably going to slow down. It will then come back on itself and then carry on in the positive direction, I'm guessing. We'll see. Okay, so when it's at rest. So it's at rest when v is 0. When the velocity is 0, you're stationary. So when v equals 0, 2t squared minus 16t plus 24 equals 0. Let's divide everything by 2. T squared minus 8t plus 12 equals 0. We'll go to our go-to method of factorizing. So we need two things that times together to make 12, add together to make 8. So it's going to be minus 6 minus 2. So t equals 6, t equals 2. So it's going to start off a speed of 24. After 2 seconds, you've got a speed of 0. Then the velocity is going to be negative, so you're coming back on yourself. So imagine you start off in this direction. T equals 2, you start coming back on yourself. And then when t equals 6, you go in that direction again. So you go up, down, down. What you ask for next? The value of t when the velocity is 64. So 2t squared minus 16t plus 24 equals 64. So bring that across. 2t squared minus 16t minus 40 equals 0. T squared minus 8t minus 20 equals 0. And this time we need two things that multiply together to give us minus 20, add together to give us minus 8. T minus 10, t plus 2. So t equals 10, t equals minus 2. So we can't have a negative time, so t equals 10. D, the greatest speed of the body in the interval 0 to 5. Well, probably the best thing to do here is to draw a graph of the velocity, and then where that graph is at its peak, we know we're going to have the greatest speed. So, if we do velocity against time, we know we start off at a speed of 24. The speed is 0 at 2 and at 6. It's going to look something like this. So 5, 4, no 6, no what was it? 6, sorry. So that's not 5. 6, 2, somewhere there, t equals 5. So we can see clearly from the graph the greatest speed in the interval between 0 seconds and 5 seconds is 24. If, say, you wanted to work, well, I suppose it could be, this might be less than minus 24, I guess, so we better work out what that point is. Now, because we've got symmetry in our, what will be a quadratic graph, we know the x-coordinate of the lowest point, the minimum point, is 4. So when t equals 4, v equals 2 times 16 minus 16 times 4 plus 24. So that's 32 minus 64 plus 24. which is what, 56 minus 64, which is minus 8. I'll put there's 4 minus 8. So although the velocity is minus 8, its speed at that point is 8, because speed has no direction, it's just its value. So the greatest speed between 0 and 5 is 24 in that interval. We could also sketch the graph by putting this into completed square form, but this is a little bit of an easier method. Okay, that's all the examples prior to exercise 11A. So we crack on with 11A now.